My name is Diane Hall. I'm the president this year for the Warren Astronomical Society. Good to see y'all. Let's kick things off with a roll call. Our tech support over there is Jonathan Cade. Hi. What's your name? Excellent.
Tina Wong.
Don.
Oh, Mike.
Maria.
Jim. Angela. Bob Berta. Gregory. Brother. Levi.
Laura.
Laura.
Mike. Jeff McLeod, Outreach.
Excellent. I think we have at least one first-time attendee. Make that two first-time attendees. Anybody else new? Okay. How do you find out about us? I know. I figured as much.
It's nice to not for the internet for that question.
Yeah. Okay. Fabulous. So, as far as presidential business goes, we've got a vacancy for secretary. So Dale Teamy and his automated assistant have been doing the work of holding down things since Charlie had to leave. But we would like to have a board member for board meetings, since it's always good to have a tiebreaker for contentious issues like whether or not we renew the insurance this year. So if anybody would like to be the secretary, let me know. It is a great way to get your feet wet on the board. It's a great introductory position. And modern technology makes the job a lot easier than it used to be. So let board@warrenastro.org know if you are interested in joining. As far as other things going, we have a fabulous event coming up April 25th from 7 to 10 p.m. at Belle Isle State Park. It's their astronomy night. So if you are interested, email outreach@warrenastro.org. Let the board know. We will provide the details. We will also have an email blast promoting it as we get closer to the event itself. So we've been looking forward.
We are. Do we have the microphones here?
Sorry, Diane.
Dale? Yes, Dale. Yes.
The microphone should be packed in
Yeah,
the bag with
Jonathan
the
found
computer.
Jonathan found them.
Okay.
So we've been looking forward to doing more events with the Belle Isle State Park people for years now. So this is a really exciting opportunity. The skies are surprisingly good there because of the barrier to light pollution represented by Lake St. Clair and the river. So check that out. Look for the email blast.
Or just go to the event.
Or just show up. Yeah, you don't have to volunteer. Just show up. Warm bodies are great.
Warning, it is the same night as the observatory open house.
Okay. The other thing that we've got on the schedule is after the Cranbrook meeting, we received a notification from Cranbrook. They are doing a science day, May 2nd. It's a daytime event, so we are looking for solar telescopes. If you are interested in bringing a solar telescope to Cranbrook on Saturday, May 10th during the daytime, second during the daytime, email the board and we will sign you up. Again, an email blast will be going out after this meeting advertising the event, so keep an eye out on that. It's being run by the head of the science group, so we'd love to have good turnout for that event. 9 to noon. Early.
And no, I am not doing breakfast that morning.
I'm going to Florida, so don't worry about me.
All right. Our IT/first vice president, Jonathan, is successfully logging into Zoom. I hear myself.
Okay, hang on.
Your turn.
No, just keep talking.
No, it's your turn for board report.
We have presentations lined up. Gary Ross will be returning in May, so for the May meeting. So don't miss it. We have our first openings in July.
And if anybody could put him up, he always needs a place to stay.
Yeah, I think he might have something set up. I haven't heard otherwise. So, uh, but he's actually going to be using PowerPoint this time, which is going to be an experience for all of us. So,
Wait, what? Who did Gary's PowerPoint? Wow.
right. Say that again, Bob.
I said, wait, what?
What?
Who did Gary's PowerPoint? That's amazing.
It's all right. One of his friends. It's what is now a because there's no camera.
Yeah, so we are,
This is
remember Gary has a lot of friends from GRAAA who are more technologically 21st century than Gary. So probably one of them. Anyway, we are looking forward to that. Anything else on the agenda, Jonathan?
not at this time, but if anyone would like to give a presentation or if there's a presentation you would like to hear, please let me know.
All right, fabulous. Riyadh, over to you at second VP.
Yeah, thank you, Diane. Hello, everyone. Last open house at Stargate Observatory was on March 28th. I could not attend, so Jeff McLeod opened the observatory, and thanks to him and to Tina Wang, who helped him out, everything went well, even though it was kind of mostly cloudy, but they started out by looking at the sun through a solar filter, hydrogen alpha solar filter, and then they were able to look at the moon, Jupiter, and the double star Castor. The observatory was opened around 7 p.m. and closed around 11 p.m. There were about 7 members there and 25 guests, including American Heritage Girls. The next open house is scheduled for April 25th. So not this coming Saturday, but the one after, starting at 8 p.m. I'm going to try to be there a little bit earlier to do a little bit of cleanup. And if somebody's there to help out with maybe with the ladder and opening the dome, that would be great. We also have scouts scheduled for May 2nd to attend at Stargate Observatory. So on May 2nd also, if there's anybody who's able to help out that Saturday, that would be great too. That's all I have at this time. Thank you.
Thank you, Riyadh. All right, over to Mark Miles at Treasury. Mark's with us at Macomb. Anything to report, Mark?
Well, I have a little bit of microphone at him. Aside from the fact that we haven't been able to turn over access to all the accounts yet.
Another grill.
Oh,
Still another grill.
Business.
Okay, thank you. I have some information to report on the financials, not an awful lot at this point because I haven't had full access to all the accounts yet. But Theme was nice enough to print off some information for me as of the end of last month. So it's fairly current, but not like up to the minute. So our total balance, then our accounts are $21,224. We had memberships so far that have been recorded this year of 201. I have a number of them in my folder here that as soon as I get access to the bank account, I will deposit them. So that's to be determined at this point. And we have had telescope sales of $1,350. I believe that actually happened in February, probably reported in March. Some minor cash items coming in at close to $4. Bank of America credit card, $188, and we paid our post office box for $188. Let's see. That should about do it. Any other questions that you might have that I probably can't answer, I'll be happy to entertain anyway.
thank you. Yes. We are having severe issues dealing with Bank of America. So once we have the
bank account sorted out, we are actually considering switching to another financial institution. So Bank of America served us well for many years, but they're not serving us particularly well right now. Our secretary position is, as I mentioned, vacant, so I'll pass things over then to Jeff McLeod at Outreach.
I think you got it all.
Okay,
I appreciate it. Belle Isle 25th, if you can't make it to the observatory, and then if you have a solar scope and are interested in helping out at Cranbrook, I'm talking with Bob Tremblay. I think he's available. The niche thing. There's not too many of us that have a solar scope.
Brilliant.
have a solar.
We have a PST. Yeah. I have a PST. Yes. We'll have at least 3. Perfect. More the merrier, though. I did have Mark Wynn of the financials reminded me that we did have a representation at the FACT swap meet, Ford Amateur Astronomy Club swap meet. It was better attended than last year, from what I heard. Still a lot smaller than it was in its heyday. Unfortunately, our hobby is a little bit insular these days. Now, the FACT swap meet never does attract too many people from the outside world, so it's mostly astronomers interacting with fellow astronomers. But it used to fill a giant auditorium, and now it's a bit smaller. So hopefully with some of the outreach events we can grow the numbers and have more representation next year.
It's also more than just a spot meet. They do lectures, they have food.
Yeah, they used to call it an expo, which I thought was a better name for it.
Yeah.
That might be a better.
You can also get a Ford Club mug.
Hey, those are our favorite mugs for soup. They're real good.
You can also get one by presenting to them. And if you present to them, you can present to us.
Brilliant. All right. Do we have publications?
WASP is up.
WASP is up, WASP is out. Email publications@warrenastro.org if you are interested in contributing to our award-winning newsletter. Okay. With that, we've got the subgroup reports. Bob, I believe you had some solar to talk about.
Yeah, I could do that. Let's see. Let's share this. Oh, that is not what I wanted to share. There we go. Okay, so from spaceweather.com, there's a hole. There's a coronal hole, a large hole that's open in the sun's atmosphere and is directly facing the Earth. High-speed solar wind flowing from this coronal hole should arrive on April 18th, potentially sparking G2 class geomagnetic storms. The new moon will provide dark skies and a nice canvas for long exposure photography of auroras. So yeah, that's a pretty mean-looking coronal hole there. There are 3 named sunspots right now. Sunspot 4419 on the left there has rotated into view, has beta gamma magnetic field that harbors energy for M-class solar flares. It's also the sunspot I predicted we'd see last meeting, because there were a whole lot of coronal loops on the side of the sun there. And I said, there's probably a sunspot there. There it is. So solar flares, NOAA has no significant flares over the last couple days. Solar wind is at 331 kilometers per second and 3.22 protons per square centimeter, which is pretty typical. I did get an alert on April 11th, and I went to the NOAA site. April 11th, I got a high solar wind alert, which is pretty rare. So I went and found that on the NOAA site. There's today's coronal loops, and again, right over on the left there, we've got a giant coronal loop and probably another sunspot rotating into view. And now for something completely different. This is pretty interesting. If you love a good mystery, look no further than the night sky in March 2026. There are no major meteor showers scheduled for March, and yet suddenly fireballs started appearing everywhere. During the month of March, reports of very bright fireballs to the American Meteor Society suddenly doubled, says Mark Hankley, who manages AMS's fireball reporting system. Many of them were visible in broad daylight and created loud sonic booms, and there's even more on today's spaceweather.com site. And not related, but interesting anyway. I get these IAU asteroid reports, and Pope Leo the 13th got an asteroid named after him in the citation here. His name, yikes, is I'm probably going to murder this. Giacchino Vincenzo Raphael Luigi Pecci, and his asteroid name is Giochini Pecci. But he had great interest in the sciences and was responsible for the reestablishment and reform of the Vatican Observatory in the 1891 within the walls of the Vatican. He also encouraged the observatory to get involved in the Carte du Ciel project, which, Jonathan, I should do a report on, or a lecture on sometime. Yeah.
Please do. Sign yourself up.
But anyway, so I was talking to Brother Guy. I said, anything interesting I should say about him? And he said, take a look at his coat of arms. There's a comet on it, which is pretty cool.
Interesting.
So
All right.
it for solar.
Awesome. So over to Riyadh then for an update on the Double Star Group.
Yeah, so the usual observing list for the spring, I'll have that with me at the next open house. And hopefully we'll look at a couple of really beautiful doubles and a couple of the constellations that are available for us to see during the nighttime hours. So come on out and we'll do some observing. Not only double stars, of course, we look at a number of other things. So come on out.
Fabulous. Do we have Tom Hagen with radio? If not, if you are interested in participating in the fun world of radio astronomy, email the board. We will hook you up with Tom Hagen, who is our radio astronomy guy. Astrophotography. Any progress with the astrophotography subgroup to report?
Some pictures of rain, clouds.
Pictures of rain, clouds, and cold weather. All right, we may have clear weather tomorrow night. So yeah, that takes us to observing reports, which I think we've all been observing the downside of clouds lately. Does anybody have any observing reports other than Jonathan? No? Well, Jonathan and I can happily report that we have journeyed to as far south as we have gone in our lives to date. We went to Puerto Rico. Specifically, we went to the island of Vieques, which has beautiful dark skies. And we did some observing of the Southern Cross and other southern objects from the beach in Esperanza on the south shore of Vieques. So that was fun. It wasn't groundbreaking, but Jonathan did take some nice pictures, including an image of Omega Centauri in the background, nothing magnified. But yeah, it was good to see the southern skies again, and hopefully we will at some point travel even further into the south to see those stars overhead. Any other observing reports?
So I have one.
Oh, excellent. Sorry, we had one question from Macomb. Latitude is 18 degrees north, Mark. Yes. David.
Okay, I have a observing report just now.
Excellent.
After having observed 44 sunspots just a few moments ago. For my quotation today, about 5 months before he was assassinated in Dallas, President Kennedy was awarded, before his assassination, he was awarded an honorary degree from the American University. And I quote from the end of that lecture that he did. For in the final analysis, our most basic common link is that we all inhabit this small planet. We all breathe the same air. We all cherish our children's futures, and we are all mortal. Such an important and pressing thing to say. Thank you very much, and back to you, Dan.
Thank you so much. Yes, and quite a sobering thought there. Okay. If there's no observing reports, then we have a bit of time for ask a question. Do we have any questions? No question is too weird. Any
This
questions?
is Tom Cervinak. I have an answer for a couple of questions. Is that okay?
That's fine, Tom. What have you got?
Well, when I gave the presentation last meeting on Native American earthworks, a couple of questions came up. The one I think most people were really interested in was there a Native American mound on Mound Road, and it's Mound Road named after that. I think I indicated that it was not a Native American mound. Um, However, I did some research, and there was about a 10-foot mound at on the present day Mound Road at 7 Mile, and it was a natural um, rise in the earth. However, it was used by Native Americans as a place to inter their family members. So Mound Road actually is named after a Native American Indian mound at 7 Mile. And however, again, it's a natural geological rise, but it was used as a burial mound. Another question came up about uh, local effigy mounds. Of course, Ohio has the Great Serpent Mound, but there was the question came up that it was out west somewhere, but close. And I did some research, and I think the person was talking about the effigy mounds in Harper's Ferry, Iowa, not Harper's Ferry, Virginia. And there's like 200 effigy mounds there of bears and birds. And it actually ended up on the Iowa quarter. So you may have
Oh my.
seen the quarter with effigy mounds on it. So
I'll have to
I
check
hope
that
that
out.
answered the questions that people had.
That's great. Thank you so much for the follow-up, and thank you particularly about Mound Road. I had no idea. I'd honestly never really thought about it.
Okay, thank you.
Say, Tom, I have to tell you, the next day after you gave that presentation, I told Connie about it, and she had taken her her eighth grade classes down to historic Fort Wayne for years, and they cleaned up the mound down there, and she gave me a half an hour lecture about how cool that mound was, and I said, I got to get her in contact with you.
Yeah, unfortunately, the Native American Museum has kind of fallen on hard times, and nobody's taking care of it next to the mound, and that's kind of sad.
Yeah.
Oh, let me add just one thing. Since we got Native Americans, and I'll throw this out. Uh, I volunteer at the Hamtramck Historical Museum, and the Smithsonian Institute has a traveling exhibit of Native American artwork and different uh, didactic kind of material, uh, traveling around to small cities. And Michigan has 6 cities that were selected, and Hamtramck got selected to be a site for the Smithsonian exhibit, and it'll be coming in May and June of 2027, and I'll make sure everybody gets an invitation.
Fantastic.
Thank
Thank you
you.
for that, Tom. Looking forward to it. Okay, any other questions? Questions for our astronomers? Jonathan, the main talk is on deck at 7:45.
Or we can maybe start earlier. If they're just doing-
Okay, it's 7:30 now, so if there's no additional questions and or observing reports, let's take a 10-minute break, and that'll give you 5 minutes to sort out tech issues with the professor. Have snacks if you got them, gang. Here at Macomb, we have snacks courtesy of Cheryl and Alan Kaplan, who brought them at Cranbrook. So fabulous. We have snackies.
Hello.
Hello.
All right, I'm going to make sure that my technical stuff is working and I can get everything up and running. I'll let you know if I need help.
Okay, well, yours seem to be working much better than what you got going in Macomb right now.
Oh, that's good.
Oh boy.
All right, let's see if I can get I'm going to practice getting my stuff up and running and just. Oh, okay.
Well, your sound's coming through very good, so for that.
Yeah, I've been told that I have a really good sound system on this computer.
Oh, good.
Bad. All right, let's see if we can share.
Okay, I'm seeing your program.
All right, so it looks like,
You want to start a slideshow?
yeah, it looks like, can you see the slideshow?
Well, I'm seeing everything right now.
Yeah,
I'm
I
not
have.
seeing a slideshow. There we go.
There we go. Okay. All right, I guess we can leave that up there until whoever's in charge gets back and make sure that everything's okay on your end.
Okay, sounds good.
Is that you that's in charge or is that someone else?
Someone else. The club is meeting in a college classroom at Macomb Community College over in Warren, Michigan. I'm clear across the state over in Kalamazoo, Michigan,
Oh, you are a little ways away.
running a streaming. Yeah.
Yeah, I'm not used to working on Zoom. We mostly work on Teams, so this is my first time
Oh,
presenting on Zoom. So hopefully everything's going to go fine.
well, it's going swimmingly so far.
All right, well, I'm going to stop sharing that
Okay.
until everybody gets here.
All right.
They're ready for me, but seems to be working, so good.
I think so. I can't tell what's going on in the classroom right now, but if you're coming through fine for me, we're both coming through in the classroom right now. So,
Oh, is that a moon globe you've got behind you, the big one? Or is that Earth?
oh, that's the moon.
That's the
Hello.
moon.
I see we have our distinguished guest of the night online.
Yes.
I'm just making sure
All right.
everything's up and running and working.
All right. So we're on a little snack break right now, so we will reconvene in about 10 minutes.
Oh
If
yeah,
that
take
works
your
for you.
time. I just wanted to make sure there were no problems before it was the last minute.
Yes, absolutely. Thank you so much. Yeah, we'll probably do a tech check at 7:40.
Okay.
All right. So they must have heard us.
Oh, they must have. Well, hopefully they're okay if we just keep chatting.
Yeah.
I had to comment on your globe. I have a big Mars globe in
Oh,
my
okay.
office. I used to have a moon too, but somebody borrowed it. It's one of those things.
Oh, yeah, yeah. Well, the moon thing is kind of interesting. Some years back, one of our club members, Gary Ross, he was also a member of the Grand Rapids Astronomy Club, and Ralph Baldwin, yeah, another club member, wrote some books on the moon, and Gary talked about it. He was doing some observing, and on the limb of the moon, he saw a real bright, shiny protrusion, which he called the shiny mountain. And he couldn't figure out exactly what feature that was. He's looking at all his moon maps and everything, couldn't come up with anything. But he had enough stuff going to give a talk on it, you know. And at the end of the talk, he held Baldwin's book up and said that Baldwin was asked why he wasn't more involved in the club. And he said, well, he just didn't want everybody leaning on him for everything. And Gary says, so with that, and he drops the book. You know? I said, well, that's no way to treat a book. You know? But then I got to wondering about it and everything, and started doing some exploring. I bought more lunar books. I have a small library of lunar books now, old and new. And it's been a source of fascination. And the one thing was libration. And I was reading up on that, and come to find out that for the moon to finally do all its rocking around and everything and return to exactly where it was when Gary was looking at it would take 80 some odd years.
Oh, wow.
Yeah, that's what I said. You know, so yeah, it's been, I got at least 4 articles for our newsletter out of it. So, you know, it worked out pretty good.
Well, that's good, as long as you can bring something you're interested in.
Yeah.
I love lunar maps. I've got one on my door that's covering up the window so you can't see into my office.
Oh, okay. Yeah, the lunar maps is another fascinating thing too. The story behind all that.
Yeah.
It's an ongoing process, not settled yet. You know, it's like wow.
So have you been a member of the Warren?
Warren, yeah, I've been a member since 2007, I believe it was. I joined.
Oh, wow. So a little while.
It's been a few years, yeah. I've been an officer, most of them. It seems like, anyways. I'm currently not an officer, but I've been secretary, treasurer, publications director, and right now just simply editor of the newsletter. We have, when I was serving as officer, we had 2-year terms, and then they went to 3-year terms. Actually, they're 1-year terms, but you can re-up 3 times now in succession before you have to turn it over to someone else. But I've been engaged with the club in some way, shape, or form ever since I became secretary, and that was like, I don't know, 2010? Somewhere around there, yeah. I don't know. It's been a minute. But we were living in East Point at that time, and oh, here they come.
Hello. Let's
Hello.
I've got the program chair here with me to see that everything's loaded on presentation.
Hi. Professor Hart, can you hear me?
Yes, I can hear you.
Did you want to start presenting?
Sorry, you guys are fading out.
Sorry, it might be this other. Did you want to start the presentation or start sharing the presentation on Zoom?
Sure, I can definitely do that. All right, is everybody okay? Can you see that?
We can
Looks
see
good
it.
here.
All right, good. No technical difficulties.
All right, excellent.
That doesn't happen
I
all the
am
time.
ready to introduce you whenever you are ready to. We can yell at everybody here to be quiet and then start presenting.
But whenever you're
If
ready.
you're ready to go. All right.
All right.
Attention!
All right, everybody. We've got our feature presenter on deck and our first vice president at the mic. So I will hand things over to Jonathan to take care of business.
All righty.
Oh, I had a sweater somewhere.
There
it is.
So-
Sorry.
Jeff.
I know. Fire me.
So
Which one?
no, don't worry. So welcome everybody to our feature presentation. Professor Janet Hart is a professor at the University of Windsor in the departments of physics in the School of the Environment, where she has taught a wide variety of classes such as astronomy, atmosphere and climate, and planetary science classes for the past 10 years. She has a master's degree in earth science and a bachelor's honors degree in environmental geoscience, both from the University of Windsor. She's been involved in public outreach for the School of Environment, and she's joining us from across the river in Windsor. So, Professor Hart, thank you so much for presenting to us, and take it away.
Oh, well, thank you for having me talk. Hello, everyone.
Hi there.
All right, so tonight we're going to talk about the aurora polaris. Mostly we hear aurora borealis, but the aurora actually happens at both the North and the South Pole, so hence the aurora polaris. So we're including both of them. And the reason that we have auroras on Earth or anywhere and that has a magnetic field and an atmosphere, so any of the planets in our solar system, but we're going to talk about Earth today, is this what happens, the interaction between our sun and the magnetic field around our planet. The sun can be very active at times, and it can throw off charged particles, electrons, and these particles from solar flares or coronal mass ejections move outwards from the sun and interact with our magnetic field. Now, our magnetic field is similar to a bar magnet coming out from the north and south magnetic poles of Earth. And it creates this field around Earth that protects us. If we didn't have that magnetic field, we'd be in a lot of trouble from solar radiation and particles coming off of the sun. So anyway, the part that faces Earth kind of gets pushed in a little bit, and the charged particles move outwards around the magnetic field and flow out the other side, pulling the magnetic field. Sorry, that's my lovely our maintenance, sorry about that, has our lights on timers now. If I don't move around enough, they just shut off on me. Anyway, so what happens is the particles pull the magnetic field, the solar wind pulls the magnetic field out back away from the sun in a tail. So it extends much further in the side away from the sun than it does in the side towards the sun. Now, the reason that we call it an aurora is actually goes back to Galileo. He named the lights in the sky after the goddess of dawn, the Latin goddess of dawn, and borealis in Latin means northern or from the north, and australis means southern. So in the northern hemisphere, we have the aurora borealis, and in the southern hemisphere, we have the aurora australis. And they're always happening at the same time. All right, so back to our magnetic field. You can see the Earth in the very small center of this picture and the magnetic field extending outwards. So the sun would be on the left of this picture and moving towards that smaller part of the magnetic field. So the shape of our magnetic field is similar to what you'd see a rock sitting in a stream as water is flowing around it, how it sort of flows around the front of the rock and it pulls out in a tail behind that. That's kind of the same shape as the solar wind interacting with our magnetic field. It pulls it out and creates a tail at the end of it. The part facing the sun is only about 10 times the size of Earth, so about 10 Earth radii, whereas the tail can be hundreds of Earth radii. And so it can extend thousands of kilometers in space. So when our sun is having a lot of solar activity, the magnetic fields of the sun can get very twisted. They create sunspots and all kinds of other activity on the sun. And that can create conditions where charged particles can flow off the sun at very high speeds towards Earth's magnetic field. And the interaction of those charged particles, so those protons and electrons, the sun's mostly made out of helium, or sorry, hydrogen, not helium, which is, proton, electron. So we get these particles that flow along with the solar wind towards our magnetic field and interact with that. So one of the things I'm going to talk about tonight is a BT value. And this is the value of how the magnetic field of our sun and how it moves outwards away from, well, let's start there. So the magnetic field of our sun, because our sun is rotating, the magnetic field spirals off of the sun and in a shape called a Parker spiral. And the BT value is the northwest, east-west, and towards and away directions from the sun. So we're looking at all the different directions. So we're looking at 3 value directions. And these tell us about the geomagnetic conditions. So when we talk about geomagnetic storms or geomagnetic interactions, that geo being Earth and magnetic being our magnetic field. So the interactions between the particles coming off the sun on the solar wind and our magnetic field can be measured in different directions. And stronger BT values mean that we have enhanced geomagnetic conditions. So a lot of activity happening in our magnetic field from particles coming off of the sun. Now, these values are measured in nanotesla, so NT. And the BT index, so we have the direction, as I said, where we're looking in 3 different directions. The BX and the BY are not as important for aurora as the BZ value. BZ is perpendicular to the ecliptic plane. So the ecliptic plane being sort of an imaginary line coming through the equator of the sun, out through all the planets where all the planets are sitting on in our solar system. So that plane, perpendicular to that is the most important value, and that is our BZ value. And sorry, minor technical issues here. All right, there we go. So anyway, this measures our magnetic field strength in like a north-south, east-west, and towards and away from the sun. So this interaction with our magnetic field or magnetosphere, the north-south direction, the BZ, is important for auroral activity. When the BZ is oriented southward, it connects with the Earth's magnetosphere, which points northward. So our magnetic bar, north-south, our bar magnet kind of. So when the BZ is oriented opposite to that, it interacts similar to two bar magnets where you've got opposites that attract in bar magnets, and you've got, when you have similar, they push away from each other. And so the BZ can wreak havoc with Earth's magnetic field during this time. This causes disruption of our magnetosphere, and it allows particles to rain down into our atmosphere along Earth's magnetic field lines. So if we look at this particular image, you can see that on the right side of that, you can see at the end of the tail, there's a red area. And the red on the right is where the electrons that produce the nighttime aurora are accelerated, and they're the source of the processes that make our geomagnetic storms. So you can see our magnetic field, the tail there is moving particles away. And in the front of it, it's pushing particles sort of over and around the magnetic field. And when we see nighttime auroras, we actually see it from the particles that are at the back that are being funneled along those magnetic field lines and moving towards Earth's north and south poles. So as it interacts with our magnetosphere, what can happen as it's pulling along the magnetic tail, those particles can pull, and we can have a reconnection event where those magnetic field lines kind of snap back like an elastic band, and that funnels those particles back along those field lines, moving them towards each of the poles. And so it sends charged particles into our upper atmosphere along those magnetic field lines. And that's why we see them north and south, because of the way they funnel along those field lines. So electrons that are moving, these charged particles, they interact with our upper atmosphere, and they create interactions with the molecules in our atmosphere. So if you see this, look at this green area here. This is the auroral oval, and it's centered on the magnetic pole, and it shows typically where we see auroras within this oval. And at certain times of the morning and middle of the night, we get different amounts of activity. So the evening shows tend to be very much quieter. When you get later, you get a lot more activity. And then as you head towards morning, again, the auroras begin to slow down. So the the geomagnetic activity, there are some sites that will give a different scale for geomagnetic activity. NOAA has their own scale for geomagnetic activity. There are other sites that do as well. But a good one that's sort of universal is a KP index. And so the KP index goes from 0 to 9, 9 being stronger and more activity, seen at more southern, in our case, southern, closer to the equator areas. And so these charged particles carry these electric currents into our atmosphere, and it changes the magnetic field at the surface. And those changes in the magnetic field are what we refer to as geomagnetic storms or geomagnetic activity. And this is where we see the auroras being produced. So the geomagnetic index, or KP, P is for planetary. The K is actually from the person that came up with that. He was German in origin, so in his language, the word, I believe it was KP was planetary index in German, where K, I don't know the German pronunciation of the word, but anyway, so that's where the KP comes from. The P is for planetary. All right, so the location and the brightness of the aurora can be directly correlated with the KP index. So if you're looking to figure out whether or not you're going to get an aurora in your area, you want to look at the KP index. And the KP index it varies with the strength of the geomagnetic storm. So 0 comes, that magnetic oval is about 66 degrees, so up around the Arctic Circle, not very strong activity and pretty far north. It increases by about 2 degrees for each level. So 1 would be 2 magnetic degrees further south. Now, that doesn't mean latitude degrees. We're talking about magnetic degrees. Anyway, so 0 to 2 is not very active. It's going to be very calm in comparison to higher geomagnetic activity, and it's going to be further north. Whereas 3 to 5, it's going to come down from the poles a little bit, and I believe that's the blue line there. And so it's down a little bit further towards the equator, and it's a little bit stronger. And still pretty far north. When we get up to around 6 to 7 is when you start to see it in the United States. You're going to see it starting at the top of Michigan and moving downwards. And so we're getting out of Canada and moving a little bit more south. The geomagnetic activity is stronger. It's moving further away from the poles. There's a lot more material interacting with that magnetic field to produce this. So when we get to a KP of 8 or 9, then you're looking at much further south and can be seen for a lot more areas in the US. Now, last year, 2025, we had some really nice auroral displays that we got to see from this area. I'm sure you guys did as well. Hopefully you guys got out and were able to get some pictures or at least enjoy it. But it was nice that since we were at a solar maximum, when we have the most amount of solar activity, that we actually got to see some really nice auroras. So when we look at what happens in the atmosphere, we see different things from different altitudes. So the northern lights occur usually between 100 and 300 kilometers in the atmosphere. And I mean, they can occur as far up as 600 kilometers from the surface. But what happens as those particles that are being funneled through those magnetic field lines, they interact with atoms and molecules in our atmosphere, and they lose energy as those interactions occur. And those interactions will occur as long as there's energy and move further down into the atmosphere. Eventually, the energy runs out and we don't see any more energizing of particles within the atmosphere. So those charged particles, as they collide with particles in our atmosphere, the collisions create these little tiny flashes of light, which is why the northern lights appear to be, instead of a steady like a light bulb, they tend to move, look like they're moving and brightening and dimming. So as those collisions occur, when the charged particle encounters a molecule in our atmosphere, it excites it, it starts to move faster, but it can't contain that energy for very long. So it releases that a photon of energy as it moves back down to its non-excited state. And those photons that are being released from those excited particles that are now settling down to their ground state or their most least energy state, they release those photons, and that's what we see for the aurora. And that's why what happens is we're seeing billions of flashes that are occurring in a sequence, and that's why it looks like it's flashing on and off and moving the way that it does. Now, the colors that we see lots of different colors, mostly greens, but they are directly due to the composition of the gas in our atmosphere and the altitude where those connections occur, where those particles are encountering the particles in our atmosphere. And we're going to see, as those particles move through our atmosphere and they lose energy, we're going to see different colors moving through. So we can see reds, greens, pinks, dark reds, purples, and blues have all been seen. I've not seen blue yet. I'd like to at some point, but all of these colors have been encountered by people that are looking at auroras. So hopefully, being able to see those, that would be fantastic. Now, green, the most common color that you see from the ground, those charged particles collide with oxygen molecules between 1 and 300 kilometers in altitude. The pinks and the dark reds are usually produced by nitrogen molecules. So as they contact nitrogen molecules, and usually altitudes of about 100 kilometers. Now, red, those encounters occur higher in the atmosphere, and they're again encounters with oxygen, but they're higher than what we see for the green encounters. And then we get blues and purple. Hydrogen and helium can produce blue and purple auroras. And although these colors against a really dark sky are hard to see. All right, so here's kind of a summary of that. So you can see that higher up in the atmosphere, contacts with oxygens produce red. Nitrogen can produce a blue glow, and then followed by also green glows. So as it's hitting a secondary oxygen molecule, sort of middle of the atmosphere, and those pinks are nitrogen in the lower atmosphere. So it's not only what particle it hits, but also where it happens to hit that particle in the atmosphere. That changes the color that we see. Now, when we talk about the auroras, whatever's happening at the North Pole is happening at the South Pole. It's a mirror image of what's happening, because those particles that are funneled along magnetic field lines are funneled simultaneously to both poles. So when we look at auroras, if you go onto any of the websites, they'll often show you what's happening at both of the poles, and you can see that what's happening at either side is the same. It's because it's caused by the same event and the same particles. So they're mirror images of each other. And so when we get an active aurora in one hemisphere, we get it in the other. And we measure things like the brightness, the complexity of an aurora, the location, as well as the geomagnetic activity. So you might see any of those on the sites that you're going to look for your auroras information from, depending on the site itself. Now, we also see different types of auroras. Auroras look very different at very different times and at different locations. These very these are called discrete auroras, and they're bright, thin bands. And you see a lot of these in pictures of auroras. And these generally occur closer to the magnetic pole as opposed to where we're at. Diffuse auroras are often caused, they're not as much energy. They look more like a green kind of fog, and we see these at lower latitudes and spread out over a larger area. And it has kind of a hazy appearance to it. It doesn't have, it's not as easy to see the patterns that you would see near the North Pole. But there are lots of different shapes and sizes of auroras, so many different types and shapes that are out there. And it depends on the magnetosphere, the intensity of the geomagnetic storms, the molecules in the atmosphere. There's a whole bunch of things that make these different shapes and these beautiful ribbons that we see. And we can even see different types of activity at different times of the night. So we might see stronger geomagnetic levels in the evening or in the middle of the night, as opposed to the evening and the morning. We might see less active. So the time that you look at the auroras are also really important. So around 10 p.m. till 2 a.m. is probably the best time for viewing. That's when the aurora is most active and best to view it. Also the equinoxes. The equinoxes, we tend to see more intense auroras in the winter. Skies are darker. Okay, we're just going to leave it this time. All right, and when solar activity decreases, we see that shrinking circle, that oval, auroral oval, stays closer to the poles. So as I said, the more active our sun is, the more strong the geomagnetic storm is, the more particles that are going to be funneled into our atmosphere, and the stronger the aurora. So keeping an eye on solar activity is also important for when we're looking at auroras. And we occasionally get some really interesting activity. But during the most active times, we can see quite a bit south of the North Pole that we can see some really beautiful auroras. But as solar, we just had our maximum last year, so we're slowly starting to decrease down to eventually to a minimum. We're going to see that the activity on the sun is going to continue to decrease, so the chances of us seeing auroras also decreases. So we get to our next, we start building up to our next solar maximum. So we can see auroras across Alaska, Canada, Greenland, all the northern countries. But in the southern hemisphere, there's a lot less land, more oceans. So there's not as many countries that actually see the auroras from where they are. There are lots of auroras that we've looked at on Uranus, on Saturn. We've looked at them on Jupiter. So any planet that has a magnetic field and an atmosphere can also have auroras. So not just us. Viewing the locations and conditions are really important. You can check forecasts through NOAA, through the Space Weather Prediction Center. We'll let you know about geomagnetic activity. And you can look at checking the aurora oval or locations in real time, keeping an eye on the KP index. And these are pretty up to date. You can also get so many different apps. There's an app for everything now. There's an app for auroras as well, and you can track and get alerts for that. So our magnetic pole is about 250 miles from the geographic pole. We got to remember that our magnetic pole is slightly off our north-south axis, rotational axis. And so things like, getting to a dark place, if you can get up on a hill, that's great. If you can get north in the summer, that's always better. And making sure that you're out later in, after 10 p.m., 10 p.m. till 2 p.m. is the best time. All right, so I'm getting to the end there, and just got a few pictures of some really beautiful auroras, different types that have been seen. But again, if you're looking directly into it, you might see this sort of radial pattern. Depends on where you're looking, but if you're looking straight up, when you have the bands coming over, you might see this radial pattern. And that's the end. So I guess questions.
Right. First, shall we have some applause?
I have a question. May I?
Sure.
This happened, if I remember correctly, in August of 2000. My family and I were camping at Lighthouse County Park, which is on the thumb of Michigan, pretty close to the tip.
Okay.
And got up to go to the restroom and realized that there was aurora borealis out. And so I walked to the dock, and I'd never seen anything like that. I've seen the Northern Lights a number of times, but tell me if this is possible. But like due north or about due north was a large circle of the aurora, and it was during a Perseid meteor shower, and the meteors were coming right through the circle, as if they were being attracted also by the Earth magnetic field. Is that possible? I mean, I saw it, and I was just wondering if meteors are indeed also attracted to the magnetic field.
I think that would partly be a compositional thing.
I mean, what do you mean compositional?
Well, most of the meteors for the Perseids are they're not metallic, so they don't have any reason to interact with the magnetic field. However, that magnetic field does interact with the molecules in our atmosphere, which could in turn have some effect on the meteor shower because they're relatively small particles.
Right. Okay. But and also the circle, which I was really surprised at. It seemed like from your presentation that that's something that is seen at times. Is that correct?
Yes, yes. There are sometimes that it appears that there's a band or a circle going across the sky rather than the waves or the ribbons.
Okay, thank you.
You're welcome.
Go ahead.
So we've never detected auroras on Venus or Mars, right?
Could you hear that?
I can't hear that. It's
Okay,
really
sorry. So the question is, have we detected auroras on Venus or Mars?
we actually have on Venus. I don't know if we have on Mars. Mars has a very limited atmosphere, and it doesn't really have much of a magnetic field. It's sort of got a little bit of remnants. So I don't know that we have on Mars, but surprisingly enough, we have seen something on Venus. And again, Venus doesn't have a magnetic field the way that Earth does. However, they have seen something similar or possibly an aurora. But Venus has such a thick atmosphere, and the way it interacts with this solar wind is very different. So I don't know if that answers that, but as far as I know, not on Mars. And on Venus, it's not exactly what we have.
Cool, thank you. I think Laura was first.
If it's supposed to be a good aurora night, is it most active at 10:30 or at 1:30 in terms of movement or change?
I think Professor Hart said the best time for auroras is around midnight, somewhere between midnight and
Between
2.
10 and 2, so those are optimum hours.
Depends what.
Yeah, it really depends on Mike.
Question, I have a question. Did the Greeks or Romans have a name for aurora? I assume they would occasionally see it.
Did the Greeks or Romans have a name for aurora, or is aurora the Roman name?
Aurora was coined by Galileo. Greeks and Romans did have names for it. I don't know what they are offhand, but yes, they did.
Very cool. So this is Jonathan. Sorry, Mark, do you have a question?
Yeah, just a quick question. I noticed in the presentation as the particles, the electromagnetic particles pass the Earth, it tapers off into a teardrop shape. Does that have the impact on the timing of when you see the aurora? Because does it emanate from the back of the teardrop or directly overhead? I wasn't quite sure exactly how that focused in.
Okay, so as it pulls it back in that teardrop shape, something called a magnetic reconnection can happen. So it pulls the tail back, and those tail can connect together. When that happens, it can actually break, and part of it, those particles continue on, but that magnetic field line will suddenly snap back towards the Earth, and then it funnels those particles in towards the poles.
So they're actually much closer than at the top of the far back of the teardrop shape in those.
They're not at the very back. Where we start seeing is about probably about 3/4 of the way back. But those magnetic field lines, as I said, they can get stretched too far, and they can connect together and snap back, and that pulls all the particles with it.
That what causes
Most of them just stream off the end of the line, but some of them will get pulled off and funneled towards Earth.
So Mark Jacobison asks, is that what causes what's called the SAR arc?
the phenomenon.
Like a high altitude arc?
Yeah, they tend to be red.
Is that a Steve or is that different than
No,
a
it's
Steve? So I guess I had a question. The phenomenon known as Steve, is that an aurora or is that something comparable to an aurora that isn't really an aurora?
I would say comparable, but not really.
Okay. So it's an atmospheric electrical event of some kind, but not a
Yes, but not from same origins.
Okay.
So what causes like a white? It looks like a white searchlight. That won't.
This might be.
What causes a phenomenon? What I would describe, it looks like a giant spotlight, like a white searchlight, and there can be like multiple of them, and they'll flicker and jump back and forth, and they go across the whole sky, like from one end to the other. It makes the sky look tiny, like God's got a flashlight and he's turning it off and on, and moving it side to side. Have you heard of that sort of phenomenon?
I do not know.
And I was.
I mean, yeah, I've seen similar things to that. Like we used to call it heat lightning, but then there's also the zodiacal light, which is the.
This is in the middle of
Okay. Oh, fascinating.
So you got color and everything.
Yeah, heat lightning or sheet lightning is just an electrical disturbance within clouds. And it often looks like it's flashing in the skies, lighting up.
Yeah, Mark's
It's
saying
caused by a negative and positive charge differential within the cloud. So it's basically a type of lightning, and that will make the sky look like it's, yeah, white and flashing, I guess.
yeah, Mark clarified he means like during an aurora outburst, some of the outbursts that we've had over the last couple of years. He's seen phenomena like that.
You might see lighter, may possibly white colors as all these flashes of different colors are occurring together. You get multiple colors together, it might produce more of a white color just because we're seeing all of it together.
Cool. All right. Any other questions from the room? Bob.
I have a question. Looked it up. Evidently, Mars does have aurora, but unlike we have here, they're very thin, green, and it's quite a. You might want to look that up. You're really interested in that.
Yeah, so Mars does have some kind of similar phenomenon of aurora.
Yeah.
Fascinating. So Professor Hart, I had a question. I've had the experience of flying to Europe, like by way of Greenland, and I saw basically three-dimensional sheet auroras, and it looked like they were under the plane. I think that was just the curvature of the Earth for the most part. But how low can auroras get?
They can get fairly low. As they're in the ionosphere, but you can get a lower edge, 80 kilometers from the surface.
Okay. So that plus the curvature of the Earth on an intercontinental flight could be a pretty good illusion.
Oh yeah, yeah.
Bob?
Also, the recent trip around the moon, they took that photograph of Earth, and if you look at the photo really closely, you can see actually a thin aurora on one side.
Oh, nice. Apparently, the Artemis 2 photo of the Earth features a faint aurora on one side.
Yeah, some of the amazing photos from the Artemis mission. But yes, I went through a bunch of them a couple of days ago, just leafing through all of them. I've got a YouTube site up there. If anybody's interested, it shows there's a little tiny video on that page of magnetic reconnection, where it shows you how the magnetic field stretches and then the particles snap back. And if you're interested in, it's a couple minute video.
Very cool.
I have a question.
Yes.
Where these magnetic lines that we see drawn, of course, can connect, or where they go back down kind of to the North and South Pole as they dip toward Earth. Is there a possibility of them bringing back some of the high energy particles where they could harm maybe living things?
Oh, yeah. I mean, we have our Van Allen radiation belts around the outside of Earth. These particles are highly energetic, and they dissipate pretty high up in the atmosphere. But I imagine if we had an intense enough disruption on the sun and there were enough particles, they could do a lot more damage. During the Carrington event, that's going back a long time, there was a large coronal mass ejection from the sun, and the particles actually caused such big geomagnetic storms that they fried telegraph lines, and people lost power in Quebec and lots of places.
Even burned down, I think, 2 telegraph jacks. Diane?
Yeah, it was incredible, the amount of damage that happened during that event, but that's such a rare event. something like that, that we know of anyway.
What would be the
Okay, thank you.
You're welcome.
So what would be like the projected BP of Carrie?
Since the scale goes up to 9, and 9 is nowhere near, say, Havana, Cuba, where Aurora got down to during the Carrington event, what is the hypothetical value of a KP for something like that?
Okay, to go down to where?
Havana, Cuba.
Okay, so that's a good question. It would have to be you'd have to be at least a 9. So if the aurora, if the leading edge of the aurora is extending that far down, I mean, you could probably see it from further away, but you'd probably need at least a 9 for that.
Okay. So they wouldn't put it up to like 12.
No, 9's the maximum.
Maximum is 9.
Yes.
Okay. Thank you.
You're welcome.
All right. Sorry, one one last question came to mind. So the BZ value is sort of up and down from our perspective, right? So when you say that the BZ is shifted south, do we really mean because they're mirrored on the Aurora Borealis and Aurora Australis? Is BZ shifting south really shifting towards the equator, basically, rather than
Yes, it's
shifting
shifting
south?
towards the equator.
Okay.
You also have to remember that those particles coming off the sun are they're not just moving in a straight line. They tend to be moving, sort of like a rolling ball of particles. You know, there's a lot of movement up and down and stuff, and that can be oriented against or with the Earth's magnetic field. So that makes a difference.
Very cool. Thank you. All right. Any last questions? Go ahead.
Okay.
You don't have.
Okay, that's okay. I just want to understand now. So the way I perceive it, as maybe has explained, is that the Earth, this geomagnetic field and everything is more. I want to say stationary. So the Earth is rotating within all that, correct? Or is it
right?
Is it electromagnetic field following the Earth's rotation simultaneously, or is it just the field is there and the Earth rotates within it?
No, it rotates with the Earth. As the Earth rotates, our
rotates
magnetic
with it.
field also
Okay.
rotates with us.
Okay.
But
Thank
the
you.
teardrop shape the teardrop shape stays oriented against the sun, right? Like a.
No, it's away from the sun. So those particles, let me go back and see if I can find. There we go. So in this image, the sun's where the yellow is on the left. And so this would normally be, if nothing was interfering with it, you'd see 2 bunches on either side. So the front gets actually pushed and flattened a little bit, and the edge away from the sun gets pulled out. So that magnetic field, the particles flow around it and kind of pull it and make it thinner at the back. Does that help?
Yeah. So the Earth, so the magnetic field lines, and what kind of is hard to visualize is that there's a bunch more magnetic field lines that are not like we're showing a cross section of them, but they're really a 3-dimensional phenomenon.
Yeah, it's really 3-dimensional. This is just a cross diagram. But as I said, you know, this what's facing close to the sun sort of gets a little bit compressed. And then as it flows around the magnetic field lines, it pulls the ones that are further away, it pulls them out in a tail.
One other quick question. I don't know if it's part of this conversation, but doesn't the magnetic field flip once in a while?
It does flip. If you, the mid-ocean ridge in the middle of the Atlantic, we have assessed that, and we can see over geologic time where our magnetic poles have flipped because new crust is made there. So it's constantly making new crust. So, and we can look in Earth's history and see when the magnetic poles have flipped over time. It's very interesting.
But not in our human lifetime.
No,
Not
no.
span of human life, okay.
Not unless you're lucky.
It'll take thousands of years to do a flip, though.
Oh.
All right. Well, thank you so much for taking all of our questions.
Oh, you're welcome.
Sorry, was there any final ones? All right. Professor Hart, thank you so much for taking the time to speak with us. This was super fun.
Well, thank you for having me.
Thank you.
And I don't know if I can tag one last thing. I have heard that the Great Lakes are the best place on Earth to view auroras year round because we don't have midnight sun and in the wintertime our dark skies are not full of precipitation as it is in Arctic regions. So I don't know if you've looked into that at all, but that's what I've been told anyway.
Well, we have a lot of moisture in the air
That's true.
above the Great Lakes, but we also are fortunate that we don't have a lot of light pollution. So, you know, there's goods and bads for viewing in this area.
All right. Things
I
again.
mean, light pollution, not over the lakes.
All right, fabulous. Thank you so much for a lovely presentation. That concludes tonight's Macomb meeting. Our next meeting will, of course, be at Cranbrook Institute of Science on the first Monday of May. So see you all at either the Belle Isle event or Stargate Observatory on the 25th, the Cranbrook daytime event 9 to 12 on the 2nd of May, or the first Monday of May for the Cranbrook meeting. We've got our customary gastronomy after astronomy. If you want to join your fellow members at Jimmy's Tavern, located behind the National Coney Island at the back entrance of it on Van Dyke, just north of 12 Mile. So that's always a good place to hang out and discuss things. Have fun, everybody, and we'll see you at one of the upcoming events.
Oh,
Thank
and
you.
for
Bye.
PBS, if you didn't catch it yesterday, Nova had a presentation on going to the moon and the Artemis project.